Welcome to another day on the Journey Shake Chem. Please do the 2 warm-up questions to the best of your ability, and we'll discuss them in a moment. In number 1, we are finding the heat of the reaction. And I know this is that type of problem because I've given enough information to get a balanced equation. And when I look at it, I see that I have a salt plus water. And I write water as HOH so that I see that it breaks up to give me hydrogen ions and hydroxide ions. And therefore, I get zinc, hydroxide, and nitric acid. And then I must balance the atoms. Now, the heat of the reaction is equal to the sum of the heat of the products minus the sum of the heat of the reactants. And it's products minus reactants. I have 1 mole of zinc hydroxide, and each 1 mole of zinc hydroxide that I look up in my thermodynamic value chart, and it is negative 642.0 kilojoules, plus I have 2 moles of nitric acid, and each mole of nitric acid is minus 207.0 kilojoules for each 1 mole of nitric acid. And then I subtract the reactants, and I have 1 mole of zinc nitrate, and each mole of zinc nitrate is minus 569.0 kilojoules. Plus, I have 2 moles of water. Now, the question sometimes is, which water do I use? Is it gas, or is it aqueous, or is it liquid? Well, I see that I put a salt into this water, and therefore it is aqueous. I'm going to use the liquid water number, which would be negative 286.0 kilojoules, is 1 mole of water. Now, on the assessment, I will give you the value, so you won't have to worry about looking up the correct value. Then I do the math. I have minus 642 minus 2 times 207 minus 569 minus 572. Sometimes it's valuable to do this number and then add this number to it, because we can often make mistakes in the signs in our math. So to avoid that problem, I have minus 1056 plus 1141, and my answer I'm going to write over here is plus 85.0 kilojoules. And it is endothermic reaction. Heat is absorbed by the reaction and it gets colder. By the positive sign, I know that it's endothermic. And that's how you do number 1. In number 2, I'm using the same reaction as I had in number 1, only it's in reverse. I'm beginning with my zinc hydroxide and my nitric acid, therefore I have a base plus an acid, and I get the salt and water. Now, I'm given 9.5 grams of each one of my reactants, so that tells me that it's a limiting reagent problem, and I will show you how to do this both ways that are possible. So first I'm going to take my 9.5 grams of my zinc hydroxide, and I'm just going to follow through mass. I take the mass of my known and I change it to moles. And 1 mole of zinc hydroxide has a mass of 99 38.4 grams of zinc hydroxide. And the way that I got that is that zinc has a mass of 65.4. And there are 2 oxygens, which is 2 times 16.0, and 2 hydrogens, which is 2 times 1.0. And I write them again: 65.4, 32.0, and 2.0. And when I add these numbers up, I get 99.4 AMU, or grams, per 1 mole. Then, to change from one compound to the other, I use the mole ratio from the balanced equation. And my unknown is the water. And I have 2 moles of water for every 1 mole of the zinc hydroxide. And once I'm at moles of water, I just change my moles back to grams using the AMU. And there are 18.0 grams of water for every 1 mole of water. And again, the AMU, I have water, I have 2 hydrogens, 2 times 1.0, and an oxygen. 2.0 and 16 gives me 18.0 grams per mole. And when I solve this, I get 3.444 grams of water. Now I'm also going to do this with my other compound. I have 9.5 grams of my nitric acid. I change my grams to moles. 1 mole of nitric acid has a mass of 63.0 grams of nitric acid. Hydrogen is 1, nitrogen is 14, and 3 oxygens is 48. And we should be pretty familiar with getting the gram formula masses by this time. Then I look back at my balanced equation. My coefficient for the nitric acid is 2. 2 moles of nitric acid for every 2 moles of water. Oh, I'm going to water. And I want to cancel my moles of my nitric acid. Therefore, my nitric acid must be in the bottom so that it cancels. And then I go to grams. And there are 18.0 grams of water in every 1 mole of water. And when I solve this, I get 2.71 grams of water. And I see that the grams of water is less when I use the nitric acid than when I have the zinc hydroxide. Therefore, my final answer is going to be the smallest of the 2 possible numbers. Now, the other way that I could do this, and I wanted to show you this way because the one that gives me the least amount is the one that's going to run out. I can only make as least amount or the smallest amount because that is the compound that's going to limit the amount of reaction. Just like if I was making a recipe and I had a smaller amount of one than what I needed, that's going to determine how much of that recipe I can make. Now, I could have also used the ratio from the balanced equation to determine what was my limiting reagent first, and I'm going to show that way. So I'll just go to moles first. So I still change both of them to moles, and for the zinc hydroxide, I get 0.09557 moles, and for the nitric acid, I get 0.19114. And when I say 1 is to 0.09557, as 2 is to X. And when I multiply this out, excuse me, I made a mistake. And this is actually 1507 moles of the nitric acid. And this is my moles of my zinc hydroxide. And so I take my recipe from the balanced equation, and 1 is to what I have, as 2, the coefficient here is to x. And my x comes out to be 0.1911. And I only have 0.15, so I have less than what I would need to use up all of this amount. And so therefore my nitric acid would be limiting, and then I would go through the mass problem as I did before to get my final answer of 2.71 grams of the water from the nitric acid. So there's 2 options of how you could do that, whichever one works better for you. But I did want to introduce the idea of the ratios from the balanced equation, because as you move up into higher levels, you will need to know about limiting reagents and how to figure those out. Well, I know that was challenging, but I know you're up to the challenge, and I can't wait to see you tomorrow.